So I'm welcome you again to the 28th EAAP webinar on genomic tools in local sheep and goat breeding programs. What would work? I think it is great to see such a large audience. Probably the topic is interesting. I hope that it will meet your expectations. We tried, at least for this. So, this, maybe I introduce myself. I am Christina Lichta and work as a research director in animal breeding and genetics in the Hellenic Agricultural Organization in Greece, in Thessaloniki. I am the chair of the EAAP Mediterranean Working Group, and this webinar has been initiated by this Mediterranean Working Group in connection with the Sheep and Goat Commission. And Georgia Hadjipavlou is organized together this webinar. So why we speak on sheep and goats? It is an important branch of the livestock sector in the Mediterranean region and has a significant economic, social, cultural, and environmental role. Small ruminant farming is widespread throughout the region in production systems that vary from intensive systems with highly productive breeds to low input systems with diverse livestock breeds and populations. The breeding programs also are implemented in several breeds at different levels of development and success. The scope of this webinar is to share experiences and tackle the various aspects of the future evolution of the sheep and goat breeding schemes, focusing on the Mediterranean region. For this reason, we developed this agenda that, this is the agenda, that include breed cases from several countries around the Mediterranean region, and we expect that we have a broad view of different experiences that will stimulate the discussion that will follow the presentation. We hope finally that we will get some answers to the question that we set in this webinar. What would be the case on local sheep and goat breeding programs concerning genomics? What changes are needed at current organizational setup? Which approaches to follow? The resources that are needed, and how to share resources and technical experience around the region, how to enhance networking, and other aspects that will be raised during the presentations. Before I start to introduce the first speaker, I think it is necessary to take some time to inform you that you can raise your questions in the chat box. The chair or me or the speakers will read the questions, and they decide according to the question if they respond after their speech, or they will move these questions to the session in the end. The webinar will be recorded and it will be available in the channel of EAAP. And I think that now is the time to ask, Jean-Michel Astruc to give the first presentation on the genomic selection in France. Jean-Michel Astruc is well known, and he is responsible for the genetic and genomic evaluation in dairy sheep. He participates in the support of several selection schemes on dairy sheep. He leads projects on novel traits and different European research projects. Also, he is the facilitator of the ICAR working group on sheep, goats, and camelids. I stop sharing the screen now, and I ask Jean-Michel Astruc to to share his screen, of course, and start his presentation. The time is 15 minutes, and I think if you finish a bit earlier, we'll have some time to respond to questions.
Thank you. Can you see my screen in full screen? Is it
Yes.
okay?
Yes.
Okay. Thank you very much, Christina, and Georgia, for your invitation and for giving me the opportunity to present the results of genomic selection in dairy sheep in France. So my name is Jean-Michel Astruc, and I work for the French Livestock Institute in Toulouse, in France. Before speaking of genomic selection, I would start with some words on the background. The first thing is that we have in France 1.5 million of dairy sheep, and that represents about 30% of the sheep population. The main feature is that we have local breeds raised in purebred in their own areas of production and in their own production systems. So mainly the Lacon breed in the Roquefort area, but more and more spread in the rest of France. Then the 3 breeds in the Western Pyrenees, black-faced and red-faced Manèche and Basco-Béarnaise, and then the coarse breed in the Corsica Island. So now, if we go to the selection programs in the French dairy sheep breeds, the main features and the current situation. The main feature is that we have a pyramidal organization with each breed having the objective to breed to benefit to the whole population. That means both creation and diffusion. And the principle of the breeding scheme was based on artificial insemination and progeny testing. The number of flocks in the selection program are above 20% of the population, and it depends, of course, of the size of the population. You can see in the line. I don't know if I can. Yes, in the line that the size of the populations ranged from 9,000 ewes to 200,000 ewes. And you can see here with these figures, the major role of AI with the percentage of artificial insemination in the selection flocks from 40 or 50% to 84% in the Lacon breed, and the high number of new AI rams each year, from 20 to 320. And this artificial insemination and all these rams allow to have a lot of genotype young rams each year, from 85 in the black-faced Manèche to more or less 4,000 in the Lacon breed. The different selection objectives are first was based on milk yield, but are now more and more balanced with selection criteria, including a growing variety of traits. Of course, these different traits have weights, and the weights are adapted to each breed. So you have here 3 examples in the Lacon breed, red-faced Manèche and Corse. And each breed select for milk yield, fat and protein, other morphology and somatic cell counts. And you can see that the weight are, if you look at the color, are quite different across the breeds, but all the breeds have all these traits in their selection criteria. On my screen, the titles are not very visible, but I will. So now, after this background, let's start with the topic, which is genomic selection. Here you have the timeline of genomic selection in the dairy sheep in France. genomic selection started in 2015 in the Lacan breed, then 2017 in the Pyrenean breeds, and more recently in the coarse breed. But actually, in 2015, the start of genomic selection in Lacan was occurred after 5 years of different programs of research and development to assess the feasibility of genomic selection. And from the start of genomic selection, we used a single-step GBLUP evaluation for the early genomic preselection. So 10 years after 2015, it was maybe time to look at the rear view mirror to see the results of genomic selection. The first thing that I would like to present are the reference populations and their consequences on the reliabilities of the EBVs. So you have is here in this figure the number of so the reference population is composed with RAMs with daughters and genotypings, and the number of RAMs in the reference populations are different across the breeds, from more or less 8,000 RAMs in the Lacan breed and to less than 500 RAMs in the coarse breeds. And according to this difference in the size of reference population, you can see here that there is an impact on the reliabilities of the EBV. Here, this is the reliabilities of the EBVs of milk yield, and this ranged from 40% to 80% according to the variation in the size of reference population. So this is a first results, and the different breeds are not equal before the results of genomic selection according to the size of the population. What is how genomic selection work in dairy sheep in France? The first thing is that the young male lambs born from assortative matings are genotyped. The name of these lambs are genomic lambs. They are genotyped and very quickly, and 3 to 5 months after their birth date, there is a genomic evaluation, a single-step genomic evaluation, and here there is a quite important genomic selection pressure. And this is the real step where there is a great intensity of selection. And here you have the results of this genomic preselection pressure. And here are the actual genomic selection pressure, which range from 20% in the Lacan breed to 50% in the other breed. That means that it is like if out of 5 genotypings, 1 young rams is selected to enter the AI center. This actual genomic selection pressure is actually quite lower than the apparent genomic selection pressure. What I mean is that, for example, there is 350 rams selected in Lacan to enter the AI center out of 3,500 genotypings. That would mean 10% of selection pressure, but actually given different selection on morphological traits and according also to taking into account the variability, the genetic variability and the different families, the actual genomic selection pressure is a little bit lower. So for example, here 20% instead of 10%. The first year of AI, in the rams are used only in selection flocks, just to maintain the reference population. And this is just the second year of the AI and further that the different rams may be used in selection, but also in diffusion. That means in flocks that are not in the selection scheme. And of course, in this scheme, there is no longer progeny test. So that means that the genomic rams, the young rams, are used directly as rams to produce the offspring and the generation. So now what is the benefit of genomic selection in these breeds? Actually, the annual genetic gain generated range from 0.12 to 0.36 genetic standard deviation. And we observe, as you can see in the figure, an increase in genetic gain from 15 to 64% in comparison to what was before genomic selection. Here in blue, you have the genetic gain, the average genetic gain before genomic selection. And here in orange, you have the extra genetic gain obtained by genomic selection. So what is the more important as increase of genetic gain is in the Lacon breed, 64, and in the Pyrenean breed, the extra genetic gain is a little bit lower. So we have an extra genetic gain due to genomic selection. Now the question is how to valorize this most efficient genomic selection. Actually, the different breeding societies have more or less decided to use the extra genetic gain to permit inclusion of novel traits related to adaptation, resilience, or efficiency. I give you here an example, which is the resistance to parasites, which has been included in the selection criteria in 2024 in the Basco-Béarnais and red-faced managed breed. And you can see that the weight of the resistance of parasites is quite important, before 24% to 35% in the Basco-Béarnais. And this is permitted by the benefit of the genomic selection on the other traits. And finally, there are also other traits that are taken into account. For example, the horn, the functional morphology, mainly feet and legs, PRP for scrappy, and also semen production. There is an ongoing criteria that will be taken into account soon, which is longevity. And then we have some other criteria which are under research and development, feed efficiency, greenhouse gases emission, and also fine meal components. So there is genomic selection, but there is also a multi-purpose valorization of the genotypings. The first valorization of the genotypings was really for genomic selection, but now we have additional use, for example, for parentage verification, and followed by parentage discovery. And this is applied to all the males chosen for genomic selection. And for example, here, the average of wrong sires is 4 to 5%. And out of these wrong sires, we are able to discover 90% of the real sire. So this is quite interesting. Sire discovery is also used on use, that means on chip in flocks that does not do artificial insemination. For example, the organic farm, and this is a way to include the organic farms that cannot make synchronization and so cannot make artificial insemination. That allows these flocks to be included in the selection program. And for example, in 2023, out of 3,500 ewes that were not in artificial insemination and where we would like to discover the sire, about 95% of the sires were assignated. Of course, as you know, there are also major genes such as PRP, SOX2, the horn, and soon new genes in the next year. There is something that could be very interesting is the better management of the inbreeding due to genotypings. This is studied in France, but not yet in routine. Now, as I said, our reference populations are composed with males, with daughters and genotypings. And one of the questions was, would it be interesting to include also females in the reference population? And the question raised in the case of the Corsica breeds. I explain quickly the background. In the Corsica breed, as I said, there are few rams in the reference population, less than 400 rams, and the addition each year is about 20 or 25 rams. So that means the increase of the reference population is very low. But on milk yield, it's not a real problem. But there was a decision in 2017 to switch toward a more balanced selection objective, and the phenotyping of milk quality, somatic cell, and other morphology started in 2017. So that means that on these traits, the reference population is very low on these novel traits. And given that, the decision was taken to make genotyping some dams of rams to allow an increase in the precision of the EBVs. Does it work? In this figure, you can see that it really works, because if you can see in blue here, the extra reliability in the different EBVs of the different traits compared to the reliability just based only on males. So there are more or less a gain of 5 to 7 points for more or less for each trait, an increase in reliability. The last point that I would like to highlight is that we, in certain cases that I will explain, go toward a genomic selection at a multi-country level. This is the case between Spain and France, with a close collaboration in the Basque Country, because there are breeds that have a different name, but which are very similar on both sides of the border. So the Manège Tête Noire and the Lacha Cara Negra, which are more or less the same breeds, and the Manège Tête Rousse and the Lacha Cara Rubia. And for that, there was a series of projects, a different project, Interreg project, which resulted in the creation of what we could call an cross-country breed society. The name is Artaldean. And with the implementation, development of a cross-country genomic evaluation between France and Spain. And for that, especially in the last project, which is RD2, the genotypings are merged and processed in interval in the framework of GenoX. And within this RD2 project, this project specifically finance interval for its own need, the own need of the project, to build a sheep GenoX. And what is interesting is that this cheap GenoX might be expanded, I think, to other situations in small ruminants in the future. So this is an example of a cross-country cooperation. Now, if I move to the conclusion, the main take-home message are that, okay, genomic selection started in France in 2015. First in Lacan, then spread quickly to the other breeds. We observe, after 10 years of selection, an extra genetic gain. I think that this extra genetic gain is highly fostered by the fact that the breeding programs are collective and organized. This is not demonstrated here in my talk, but finally, the genomic selection was quite cost effective because there was a higher genetic gain. I explained that. but also because there was we observed a decrease in the cost of genotypings compared to 10 years ago. There is, at least in France, a real market for the genotic RAMs, the genomic RAMs. That means the RAMs that are genotyped, but not that does not enter the AI center, but which are sold for natural mating to breeders. So this is a real market with a higher price of the RAMs. And there is a multi-purpose valorization of the genotypings. And the last thing is that the higher efficiency is used, as I say, to include novel traits in the selection programs. And the last slides is about some pending questions and some perspectives. I mentioned the perspective of a cross-country selection and a cross-country evaluation. So that could result in an increasing of the reference population, especially to compensate smaller population in selection compared to cattle. And that could also result in increasing the accuracy and the selection intensity. One of the problems is that we have to handle the fact that we have local breeds, mainly local breeds, and not a lot of international breeds. So maybe it's difficult to mix different breeds, different local breeds. There are various issues to tackle, technical issues, legal issues, for example, for sharing data. But there are some initiatives, and I think, for example, the webinar today is an initiative to promote and facilitate networking and actions across countries. And I also would like to mention, and this is the last point, and is that the ICAR Sheep and Goat and Camelid Working Group proposed to build a EU reference center in small ruminants to produce harmonization services and incentives in the field of performance testing and genomic and genetic evaluation, but with a specific focus on genomics. And even though this EU reference center, there is the European Union, but the outcomes could be interesting beyond EU and for countries that are not in the European Union. So different initiatives, and I think this is my last point, and maybe one of the most important point. And I thank you for your attention.
Thank you, Jean-Michel. Thank you very much. I let you speak a bit more because there are 10 years of genomic selection, so there are a lot to say. And also you brought up some topics that will be discussed in the discussion. So we'll think about it during the session. There are two questions, one question in fact. Do you want to answer is, or very, very briefly, of course, you said it in the slide, but if you want to repeat it, about the genetic gain. It was a question why Lacan has greater genetic gain than the other breeds. You mentioned, but maybe you need, and
yes.
what is the reason of 5% wrong sire assignment? There are on the chat, but maybe you didn't see.
The main reason is that the Lacan population is the most important population in France, and it allows to have more RAMs, more AI RAMs, more genotypings, and so an efficiency that is higher than the other breeds that have lower population and not the same capacity to have a greater genetic gain.
I think we move to the second speaker, and as you mentioned, the cross-country genomic evaluation. We will continue with Itasne Granado, if I'm not pronouncing very correctly.
It's okay.
Forgive me. From the Department of Animal Production of Niger. And she collaborates and works with the Latza dairy sheep breeding program. She works on the genomic selection from technical and an organizational point of view for production and functional traits. She's involved in conservation programs in the Basque Country. So we are happy to hear you.
You can see the full slide. Okay. 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 First of all, I would like to thank the organizers for giving us the opportunity to share our experience in the implementation of genomic tools in small ruminants breeding programs. And in this second talk, I'm going to speak about the Latza dairy sheep. This is autochthonous dairy sheep from the Basque Country and Navarra, which are in the north of Spain. And together with Manès and Basco-Bernès, we are the Pyrenean dairy sheep breeds. In Latza, there are, as in Manès, there are two strains. The blonde, the one, it's a Latza cara rubia, which nowadays is the bigger population. And then we have the black strain, and it's split in two populations, Latza cara negra from the Basque Country, and Latza cara negra from Navarra, which is the smaller one. These three populations are morphologically and genetically different, and they have each one have their own genealogy. So there are 3 different breeding programs, 1 per breed. The main breeding goal is milk yield, and as you can see in the graph, the genetic progress of milk yield has been positive and constant over the years. The breeding program is totally established. We have a genetic annual gain of 4% in milk yield. And currently, we also select for other characters as milk composition for fat and protein, because this milk is mainly used to produce cheese. And also we select for other morphology. And in this timeline, you can see the evolution, the constant evolution of the breeding program. It started in 1982 with the milking recording program and the first artificial inseminations. And since then, they have done many methodological improvements, and new breeding objectives have been implemented. And they started genotyping in 2011. Finally, the genomic scheme was implemented in 2021. So now we're going to go through some of the works done to decide if really moving toward a genomic scheme was worth for the case of the Latza breeds. So what did we do? The first step was to check if the inclusion of genomic information was going to improve the prediction accuracy due to its importance to increase the genetic progress. One of the first studies were done with the available genomic information, which were only artificial insemination rams. Here you have the distribution of the available rams at that moment for Latza cara negra from Euskadi and Latza cara rubia, because in Latza cara negra from Navarre, the reference population was too small. We just were focused on these 2 populations, and we did a cross validation. And in this case, what we found were that the bias and the slope of the regressions were small, but for the accuracy, we did not find any increase or decrease when we include genomic information. So the next question was, what can we do to improve this prediction accuracy? And we decided to do a simulation study to test the different genotyping strategies, and we compare them with the relative difference in accuracy, comparing all the time genomic and pedigree evaluations. And as Jean-Michel says, what we found was that including, in this case, we have in orange only females genomic information, and in purple, combining males and females. And when we include both genotypes, the prediction accuracy was higher than only with males. So based on this study, we decided to do a combined genotyping. And some years later, following this strategy, we had around the 50% of the genotypes are artificial insemination rams, because we continue genotyping rams. But then we also have females, which are the mothers of the artificial insemination rams. And also we genotype some natural service rams of the herds with a high knowledge of genealogy. Here you have for each population, which is the distribution of the genotyped animals. And then we do another cross-validation to check if really including genomic information was beneficial. And we found that again, the bias and the slopes of the regression of pedigree and genomic evaluations were quite similar. But in this case, for La Chacara Negra from Euskadi and La Chacara Rubia, that we have almost 1,000 genotyped individuals, we achieved a 40% of increase in accuracy when you include genomic information. And for the third population, with almost 500 genotyped individuals, we found a 5% of increase in prediction accuracy. So what was the next step? We need to decide which organizational changes were necessary to implement a real genomic scheme in the LACHA breeding program. Focused in this case on the selection intensity and the generation interval. So the step-by-step of the implementation, like resume, in 2020, we did the first genomic evaluation. In 2021, the mothers of the candidates for the Artificial Insemination Center were selected by their genomic breeding values. And finally, in 2022, we select the candidates for the center by their own genomic values. So what does it imply in our daily routine? Here you have like the key points of 1 year in the LACHA breeding program. The candidates for the center are born between November and February. So in a classic scheme, there was a first enter to the Artificial Insemination Center in March of around 60 male lambs. And in May was a second enter to the center of another 60 lambs. And what has changed with the genomic scheme? Now in March, well, the limit is March to genotype all the candidates to the center. So we do another genetic evaluation. And with these genomic values, they select these candidates, and around 80 lambs enter to the center. So in this case, what we do is to genotype more animals, twice the needed animals, and then among these animals, we decide which are going to enter to the center. So in a more general point of view, if in a classic scheme, we were selecting lambs with around 50% of reliability, and we use them with a year and a half. They did the first inseminations, and then there was a layoff of a year to start using them for diffusion when their reliability was around 70% with 16 daughters. And now with the genomic scheme, we are selecting the lambs with a higher reliability and a higher selection intensity. And after the first inseminations, they are directly used. There's no layoff, so they are used 1 year earlier. and they achieve the same reliability with less daughters, because we already have their genomic information. So to sum up, what we achieve is the early use of proof RAMs. They are almost 1 year younger. So what the result of this is to decrease the generation interval, and also that there are less RAMs at the center, which is an economic benefit. And just to have an idea of what we are doing currently, we have some old genotypes with Illumina, and now we are genotyping with Affymetrix, so now we have to combine both chips. And we have around 4,500 genotyped individuals. With, as I already said, with artificial insemination RAMs, females, and some natural service RAMs. And like you can see, we continue genotyping all the artificial insemination RAMs that enter to the center. And then our extra are those females, their mothers, and some natural service RAMs. And as I said, they are 3 populations, so we have to do 3 different genetic evaluations. For the biggest populations, we have almost 2,000 genotyped animals, and nowadays in La Chacara Negra de Navarra, they are almost 800 animals, and we are genotyping around 300 animals per year. So to sum up and to have an idea of the pros and the cons, what we achieve including genomic information, it's a gain in accuracy. At that moment was these percentages, but we are hoping to, especially in the case of La Chacara Negra from Navarre, to increase this gain in accuracy. It gives us the possibility to select over a larger number of lambs, and also to shorten the generation interval due to that earlier dissemination. There are less males at the artificial insemination centers. And as Jean-Michel says, it also gives us the possibility to correct some mistakes in genealogy. Also, LACHA is the other side of the international evaluation that Jean-Michel comments. Having this genomic information gives the opportunity to take this type of tasks and collaborate with other breeds. And also we are doing some co-ancestry studies to analyze how the mixes between LACHA and manets are affecting the genetic diversity of the population. And among the cons, it has been a real challenge from an organizational point of view, because it has many effects to different organizations, different people. It requires that previous genomic evaluation to select the lambs. The enter of the lambs to the artificial insemination center, it's later. And also we have to manage those genotyped lambs that are not entering to the artificial insemination center. Another key point was to combine different genotyping chips. From a methodological point of view, we have to deal with the use of unknown parent groups, which to model the missing pedigree, but they are more problematic in genomic evaluations, or the inflection of breeding values, or the imputation. And last but not least, I would like to acknowledge all the people involved in the LACHA breeding program, which are, of course, all the breeders that make this possible, the Confederation and all the breeder associations, Basque government, Spanish government, and all the scientific research projects that give us the opportunity to analyze new aspects, try new breeding objectives, and work with other breeds. here you have the QR to see what all the things that we are doing in this RD2 project. And that's all. Thank you.
Thank you very much, Jasne. Very interesting to see what do you search and how do you implement the genomic selection in the large breed. There is a question, but maybe you will respond in the chat, and we keep time for the discussion because we have already out of the time. I ask Maria Specker to start sharing her screen to present. She's from Croatia. She works on the Croatian Agency for Agriculture and is responsible for the genetic evaluation of dairy cattle, sheep, and goats. She works on genomic selection and designing and optimization of breeding programs. So
thank you, Christina, for a nice introduction. A short introduction of sheep production, which has a long tradition in Croatia. Sheep breeders raise around 483,000 animals, and among them 37,000 is under breeding activities. In contrast to continental part of Croatia, where imported large-size breeds have been raised in the Mediterranean part of Croatia, which includes many islands, as you can see from the map, Adriatic coast and Dalmatian hinterland. Autochthonous small-sized breeds have been reared for either meat or milk production. Milk is used for production of cheese, traditionally in small dairies or in a large industrial one, however, in a small extent. So in the Mediterranean part of Croatia, two breeds are under selection and breeding activities. Those breeds are Istrian and sheep breeds. More about Istrian breeds. As you can see, the breed has very fancy look, Roman nose, horns color. And the breed is reared on the Istrian Peninsula. Compared to my previous speakers, the population is quite small. It consists of 3,000 ewes. However, under breeding and selection activities is around 860 ewes, 35 rams reared in 12 flocks. This is a dual-purpose breed with a lactation production of 180 kilos. The second breed, which is under the selection activities, is Pug sheep, which is reared on this island, Pug Island. It is a little bit larger population, 28,000 ewes, and around 3,500 ewes are under breeding activities, and 114 rams reared in 27 flocks. In comparison to Istrian breed, the lactation production in this dual-purpose breed is lower, which is quite understandable because the Pug sheep is reared in very harsh environment, where during the winter period is a strong wind that blows in some cases more than 200 kilometers per hour. However, the island is full of aromatic plants, and the forage is enriched with the sea salt, which gives a special taste to this quite expensive Pug cheese. What is common for both breeds is native mating. So again, in comparison to my previous speakers, in this population, there is no any kind, any artificial insemination. The main activity in the breeding program is milk recording, which is conducted according to ICAR rules, and more recently we renewed the ICAR certificate of quality. Dairy traits that are included in the breeding program are milk yield, fat and protein yield and content, and somatic cell account. Since the main goal of the breeding program is to increase milk yield, we are trying to do through the selection activities following the pedigree prep, where beside the pedigrees, dairy test records have been used. As I already mentioned, in the population of Istrian and pug sheep only, native mating is used, which causes some issues in the blood genetic evaluation, namely due to no or limited exchange of genetic material. The flocks are quite disconnected, which is actually an issue of disconnectedness in many small ruminants and beef cattle population, where there is no or is limited use of artificial insemination. And unfortunately, this issue is neglected in some breeding programs. However, BLAP is not magical, so due to these issues, there is an impossibility to disentangle genetic from environmental effects. In order to overcome these difficulties in the breeding program, we started with new activities. So in order to improve dairy performance due selection and to maintain the existing genetic variability, we started with the use of genomic data by implementation of basic principles of genomic optimum contribution selection in order to provide selection progress for dairy traits with a minimal loss of genetic variability. In this very complex process, our breeders have support of Croatian Agency for Agriculture and Food from Association of Sheep and Goat Breeders in the Istrian region. Agency for Rural Development of Istria is very active, and of course we have scientific support from the Faculty of Agriculture. So when we started quite late in comparison to Italy, for comparison to France and Spain. So the first genotyped animals were in 2018, thanks to funds from a rural development program. But the main activities started with the project of the sheep in 2020. And by using these funds from the project, from the program of rural development, and by funds of breeding association, we genotyped almost the whole breeding population of Istrian and pug sheep, namely 4,200 animals. And on this slide, you can see the number of genotyped animals by breed and by sex, and it's quite different in comparison to France, let's say, because we decided to genotype the whole population, because this is the small population, and if we genotyped only this small amount of rams, there will be no any beneficial in the selection process. So this is the distribution of sampled animals in the Istrian Peninsula and Pug Island. A few words about OCS implementation, which is in ongoing phase. We actually do transition from the pedigree-based to the BLAP to the single-step JITN block, where the additive relationship matrix was combined with the genomic information, and A matrix has been replaced with the age matrix. As I already said, we are in the phase of development of pipelines for routine genomic evaluation, following and using a BLAP 90 family of programs. Special thanks going to our colleagues at the Roslin Institute, to our colleague Ivan Pocerich especially, who was all the time on disposal and free available for all our questions and doubts during the developing process. How it looks like, a few inputs for PACship. For phenotypes, we use lactation records. Actually, we started it with the test day records, but during some discussions, we decided to use the lactation records instead. Besides phenotypes, there are also a pedigree for all available animals and genotypes, of course. In the first step, we did some classic cleaning of SNPs following standard rules. But I have to emphasize that one of the most important benefits for our population, since we are using native mating, is check for parent progeny Mendelian conflicts, which enables us to discover all discrepancies in the pedigree. In the next step, matrices were created, and after the estimation of genetic variance for additive, permanent environmental effect, and residual variance, we got the solutions or GBVs for all the animals. We also tested SNP BLAP, and in the case when many young animals and are genotyped, and the faster prediction is essential. This is an additional step in the process of genomic evaluation. This slide shows several post-hoc analyses. And on my left side, you can see a plot of two largest principal components, while on the right side you can see Manhattan plot, which is obtained from the single step by backsolving DGVs to S&P.
Maria, sorry to interrupt you. Can you try to go to the final slide, because we are really getting out of time.
Okay.
Sorry about this, but
I'm
if you go to the main
only
conclusion, because we need also to have some discussion in the end. Sorry.
Okay, but as I already said, this is the program that shows all the discrepancies in the pedigree. About international initiative, Jean-Michel already talked, and the last but not the least is using genomic data in Istria and goat in the conservation purposes. And the results of this analysis will be presented this week in the international conference. And to conclude, the genomic data in our two selected population gives opportunities for parentage discovery beside the selection. However, the main obstacles is disconnection of flocks, and as I said, non-genetic effects where the tourism is more profitable than sheep breeding. And thank you for attention.
Thank you very much, Maria. Sorry for the interruption, but we have time to speak in the end. And there is, I think, one quick question for you in the chat, and we move to the next speaker. who is Georgia Hadzipavlou. And I will ask you to speed up. And okay, I will introduce you also that you are the chair of the Ship and Goat Commission and the vice chair of the Mediterranean Working Group. Now your presentation is ready. I don't say more. You work on the Agricultural Research Institute in Cyprus, and you are leading the programs on genomic and breeding programs and genomic evaluation in Cyprus. So thank you.
Thank you, Christina, for the introduction, and good afternoon, everyone. Today, I will present an overview of the first steps in implementing genomics in sheep and goats breeding programs both in Cyprus and Greece. And first, I would like to thank Dr. Antonios Kominakis and Dr. Christina Ligda for providing the data for Greece and also for the great work that they are doing. So I will first provide some information separately for each country. I will touch upon the small ruminant populations in each country, the main breeds and their breeding programs, and I will focus on the first steps taken for genomic implementation in these breeds. And finally, I will end with the common constraints for implementing extensive genomic evaluations in the two countries, and also the next steps that we envisage. So sheep and goats in Cyprus, they are a major part of animal production. Even though the country is quite small, we have more than 255,000 productive ewes and 167,000 productive goats. And there are flocks that only have sheep, some have only goats, and some have both sheep and goats. The main commercial breeds are the Kio sheep that comprise about 20% of the whole population, and the Damascus goats, which again comprise about 23% of the whole population. Both of these breeds are dual purpose, with the main weight put on milk productivity, and due to the higher price of the milk that is used for cheese production, mainly for halloumi cheese. And the majority of the population on the island is actually crossbred. And in addition to the commercial breeds, we have two endangered breeds, the Cyprus fat-tailed sheep and the Macheras goats. You can see the Macheras goats here and the fat-tailed sheep here. So, as with the two breeds that Maria has described, so we are actually very new in Cyprus in terms of establishing breeder societies. So these were established from 2019 onward. And you can see them here. So they cover all four major pure breeds on the island. And the two endangered breeds are also covered by the Rural Development Plan measure on conservation of traditional farm animal breeds. And there is the Cyprus Kio sheep and the Damascus breeds have been under genetic evaluation for many decades, since the 1980s, with good results. But in recent years, we have taken concerted initiatives through two projects, the AgriScience Research Project and the Genomic project, which is funded through the Recovery and Resilience Plan of the EU, to provide initiatives for private farms to enter the effort of creating a genomic reference population for the Cyprus Kio sheep and for the Damascus goats. So this project, the Genomic project, started in 2022, and up to now, we have been able to extract DNA from more than 13,000 Cyprus Kio sheep from 23 farms, and about 4,800 Damascus goats from 9 farms. And from these very same farms, we collect information on pedigree, milk production, and milk quality. And so far, we have been able to do genomic analysis for close to 4,000 Kio sheep and for over 4,500 Damascus goats. And this genotypic analysis, I mean, we also consider them to be multi-beneficial for the breeders, because we use them to help with parentage assignment in cases where the pedigree is incomplete, and these are very often the case, and also to estimate inbreeding within flocks and across the populations. And we are in progress of developing the genomic evaluation program, and to use the GBVs and provide relevant mating consultation to the reference population flocks. So, so the results from these two projects have also been utilized for research purposes in order to update and to gain a more precise estimation of selected trait heritabilities. These involve both milk traits and also other traits that we are investigating and we would want to include in the breeding goal eventually. And this would be reproductive traits and also traits such as productive life or longevity. And so these are some research results from side results from the genomic activities within the two breeding programs. And as I mentioned before, for the Cyprus skier sheep and the Damascus goats, the breeding program has started in the 1980s in nucleus flocks, in which milk quantity, fat percentage, growth rate, and fecundity have been the traits under selection. And we have also incorporated genomic evaluations in these flocks, along with all the private flocks that are included in the projects. And also, as with the case with Croatia, all flocks use natural mating in Cyprus, which of course delays the genetic progress. So on this graph here, you see the development, the genetic strength for milk yield total over the years since the 1990s up to today. So the breeding program, even before incorporating genomics, has been effective but slow. And this is again because there's no advanced reproductive management. And there is a lag in the progress, in the genetic progress around years 2000, and that's because the National Scrape Eradication Scheme had started back then, in which case the selection for the resistant ARR genotypes for sheep had overcome the selection for milk traits. And we believe that if we use genomics and advanced reproduction of elite animals, we can expedite genetic progress in the following years. In addition to the previous results, you can see here a snapshot of the GBVs for the males and the females in the ARI nucleus flock from the recent years, 2023 and 2024. There is substantial genomic variation, and the prospects of selecting elite animals for reproduction is present, and that to expedite genetic progress for milk yield. So now I will move to the data from Greece. So Greece has a very big sheep and goat population, over 7.4 million of productive sheep and 3 million productive goats. There are 25 sheep breeds and 2 goat breeds. 20 of the sheep breeds are endangered and 1 of the goat breeds. And these endangered breeds are receive support through the RDP Action 10.1.09 in order to follow their conservation activities. And in addition to that, the breeds, there are 10 breeding programs for sheep breeds and 1 for goats. And these are all supported by the RDP Action 10.2.1 on genetic resources in livestock. So this table shows the flocks that are under performance recording and the number of recorded ewes for the sheep breeding programs in Greece. In bold, you see the 3 main commercial sheep breeds. And the asterisk indicates the flocks that are under genomic selection activities in which genomic selection has been initiated, actually. And these belong to the Lesbos and the Frisarta breeds. So the Lesbos breed is managed by the Lesbos Sheep Breeders Association, and its breeding program has started in 2017. Whereas the Frisarta breed is managed by the Farmers Cooperative of Western Greece, and the breeding program had started much earlier in 2009. And both breeds are under have Professor Antonis Kominakis as the scientific supervisor of their breeding programs. And the breeding program under Action 10.1 covers gives some funds to the associations to collect pedigree data and milk yield data for both breeds, as well as milk content and other morphology data for the Frisarta breed. And it also has an action on genotyping. So genotyping of selected animals is possible through this action in order to define the scraping genotype for both breeds, and also to estimate GBVs and initiate genomic selection. So here you see some results for the Lesbos sheep. So it's obvious that the mean total milk yield, it's in the yellow line, has been increasing through the years, even though the breeding program has been active for only 6 years. And also you can see the distribution of EBVs for milk yield for years 2022 and 2023, and the violin plot for the selected animals that have been genotyped. And we should mention that the Lesbos sheep is under a pilot application of artificial insemination of selected rams that are used for genetic improvement. For the Frisarta sheep, again, we can see here the distribution of milk yield through the years for the last 6 years. And it is evident that the mean milk productivity has increased. And this is expected since the breed has been in a breeding program for a longer time, for 16 years. And again, in this breed, some selected rams and selected ewes have been genotyped. And we can see here the distribution, the overall distribution of the EBVs of the animals in the breeding program for years 2021 and 22, and a box plot of the genomic breeding values for the 57 best rams in the last 2 years. And artificial insemination has been routinely implemented in the Frisartan sheep for genetic improvement and has good results. So coming to the common constraints for Cyprus and Greece, well, these are no different than they are for many Mediterranean countries. The fact that it's quite expensive and labor intensive to collect information on pedigree and performance data. And this is even without considering the collection of genomic information. There are issues in implementing artificial insemination on a wider scale. And these are economic, but not just economic. And on top of that, we have the costs of genomic analysis. I mean, in both Cyprus and Greece at the moment, these costs are covered by different actions, different funds, but these funds are not permanent. And of course, they do not cover genotyping of as many individuals that would be necessary to really expedite the genetic progress. So the further steps that we envisage, as long as the breeder associations have sufficient funds and know-how and experts to consult with them, is to upgrade the breeding programs by extending performance recording to include milk quality traits to allow for selection for fat and protein yields, and also to add reproductive, conformation, and health traits in the breeding goal. and also to pursue wider implementation of genomic evaluations. And another major point to expedite genetic progress is to be able to implement successfully advanced reproductive technologies, including AI. So with this, I end my presentation. I thank you for your attention, and I'm open to questions if there are any.
Thank you, Georgia, for presenting also the first the work that is done in the two breeds in Greece. And I think that the discussion will follow. We continue with Antonello. Antonello? Yes, we continue with Antonello Carta from Sardinia. So we'll go to another island. So Antonello is the lead researcher on genetics and biotechnologies of Agris, Sardinia. Member of the National Committee in Italy in charge of planning national selective breeding programs for dairy sheep.
Do you see the screen?
No.
No.
I see myself, and I prefer to see your presentation. Can we move maybe to the last presentation if Badr is ready?
I think we are okay now.
Oh, okay. Sorry.
Is it okay?
You need some push, yes. Okay, and be on time, please, because we're or less than time to have some discussion. Thank you.
Okay. So good morning to all. I will present you the results of a project managed by the Italian Association of Sheep Breeders, aimed to define how we can move from traditional breeding to genomic in the Sarda sheep breed. So just a quick look of what we did in the past. We had, until 2017, we had a quite efficient breeding scheme with an important number of farmers participating to the herd book, official milk recording for the main production traits, a good rate of artificial insemination, more or less the 10% of the replacement were produced by artificial insemination, and the farmers were quite able to apply the single-cell mating. So we had quite efficient condition to have a good genetic gain for the main production traits. After 2017, we had a lot of problems due to the reorganization of the system of milk recording, the breeder association. So now we have a lot of issues to start with the breeding scheme, to restart with the breeding scheme, because we have insufficient rates of artificial insemination and single-cell mating. So a small effective size of the selected population, even if we have a lot of farmers in the herd book, they don't produce quite accurate data. We have a few recorded traits and low accuracy of phenotypes, so low accuracy of pedigree, and in any case, even if we improve these aspects, we will have a lot of difficulties to apply large-scale recording for innovative traits related to feed efficiency, methane emission, adaptation to climate change, and disease resistance. So we have to move to genomic selection. We can't no more hope in finding a few markers with large effect on quantitative traits, so to apply genomic information with quite simple methods, because our long trials did not allow to identify mutations with large effects on quantitative traits. We can just select for resistant to scrapie and another disease quite important in Sardinia, Medibisna, just looking at one locus. So we have to move from to genomic selection. And the approach we have available, we know, is that applied mainly in dairy cattle, but we learn today also in French sheep breeds. This approach is based on large-scale recording of traits for bulls of reference population, and also on the wide use of elite bulls to maintain the reference population. This approach is quite difficult to apply in the southern dairy sheep because, as I said before, it's very difficult to have a well-structured male reference population to estimate SNAP effects due to the less accurate progeny test. So low average number of daughter per side, no genetic connectedness among flocks, and low accuracy of performance recording. So the French breed approach can be applied in Sardinia, and in any case, I think this is common to all the sheep breeds. Increasing accuracy in sheep is more relevant than shortening in generation interval as in cattle. We have also economic issues. In any case, even if the price of the genotyping, even if the cost of genotyping are lower and lower, they are relatively high if compared to the economic value of EU and to the number of traits we record on sheep breeds. So what we tried to study and to propose for the future in the Sarda breed is an approach, an innovative approach based on 3 flock tiers and a ram collection center. So the first tiers that we call the genomic flocks are flocks where we apply intensive protocols for traditional traits. We measure innovative traits that are difficult or costly to measure on large scale. We genotype the whole population of the flock with medium density DNA arrays. Whole population means mainly females. And we perform the next generation sequencing of more influential animals for imputation and further studies to identify as significant SNP markers. The second tier is the traditional breeders. The traditional breeders apply the routine protocols for the traditional traits, for the traditional production traits, milk and milk composition. The pedigree recorded through single-sire mating, artificial insemination, or the parental assignment by DNA, and the genotyping only of the selection candidates, mainly males. The third tiers is the simply users, where we apply just the genotyping of the selection candidates. So this system of farmers should produce the genomic JBV estimation for the selection candidates of the 3 tiers of the genomic flocks, the traditional breeders and the users. Which reference population to produce the JBV estimation? For the innovative traits, just the genomic flocks. For the traditional traits, the genomic flocks, but also the traditional breeders that in any case produce a quite important number of phenotypes. So to try the efficiency, to try to assess the efficiency of this approach, we used 2 experimental farms of Agris and the protein content as a trait as an example. So the first tier, the genomic flock, was represented by the experimental farm of Monastir, that is an experimental farm of Agris in the south of Sardinia. The second tier was another experimental farm of Sardinia in Bonasai, and the third tier was all the other farms of the herd book. We tried to check the potential efficiency for both the innovative traits, where the phenotypes are recorded just in the genomic flock of Monastir, and the traditional traits, where the phenotypes were produced not only in the genomic flock of Monastir, but also in the traditional breeder farm of Monasai. So just a quick history of the Monastir farm. We started with this genomic flock around 2000. Every year we produced 250 replacement use, which were recorded for a lot of traits, and we tried to use rams coming from all the bloodlines represented in the Sardinian commercial population. So, which data were available to check this approach? From the genomic flock, we have phenotypes and genotypes for around from more than 5,000 use. So a lot of data with intensive protocol for traditional milk traits and other traits measured, other innovative traits measured. The genotypes were all the whole animals of the flock, so all the ewes and also of the males. Finally, we had more than 5,000 ewes that can be used as a reference population and 252 sires. We had also genotyped 582 selection candidates between males and females. In the traditional farm of Bonasai, we had the recording protocol typical of a traditional breeder. Milk recording with the ICAR methods, more than 9,000 lactation, more than 5,000 recorded use, and the genotypes were related just as a reference population just to 169 out of the 356 sires used in the flock and 487 selection candidates, that is young males. We had further 722 genotypes of selection candidates from other flocks in the herd book. So for all the selection candidates, we calculated the genomic breeding value using data from the genomic flock and from the traditional breeder flock. We calculated the accuracy of the GABV using the traditional formula, and we compared the calculated accuracy with the reference, with the benchmark accuracy that was the average accuracy of a pedigree indexes of selection candidates produced by sires with between 15 to 20 daughters and dams with 2 or more lactation. So is the traditional pedigree we apply in the past in the herd book with the traditional BLAP evaluation. The benchmark accuracy, the accuracy of this pedigree was on average 0.64. So looking at, the results, if you apply this approach for traits difficult to measure, that means that the phenotypes come just from the genomic flock. All the other animals are without record, just genotyped, then we can consider them selection candidates. We have these results that for the selection candidates that come directly from the genomic flock, almost all have an accuracy higher than the benchmark accuracy, higher than the traditional pedigree index. And this is quite obvious. If we move to the selection candidates, that is, those coming from the traditional breeder flock and from the other flock participating to the herd book, we have that just the 20%, about the 20% of rams had an accuracy higher than that of a pedigree index. Obviously, the most part of the rams showing higher accuracies come from the traditional breeder flock of Bonasai, due to the fact that we have a lot of exchange of animals from the two farms. So this farm is very well genetically connected with the genomic flock. For the rest of rams coming from a genetic farm of the herd book, just the 5% of the rams showed accuracy higher than that the benchmark accuracy of 0.64. If we move to the traditional traits, where the phenotypes, the information, the reference population come from the genomic flock with intensive protocol, but also from the traditional breeder flock, the second farm, the traditional breeder, where the phenotypes are recorded less precisely, and we have just a little portion of males of size that are genotyped and can contribute to the reference population. In this case, for this kind of traits, the selection candidates coming directly from the genomic flock had almost all an accuracy higher than the pedigree index. And you see that their accuracy were very high, similar to those of elite rams with the traditional BLAP evaluation. Also, the selection candidates coming from the Bonasai farm, that is a farm well connected with the genomic flock, show high accuracies. Cioè, their accuracy were much higher than the threshold of the pedigree index. On the contrary, when we move to the selection candidates coming from the other farms of the herd book, just the 16% showed accuracies higher than that of the pedigree index. So we have to try to work to bring this farmer to the situation of the Bonasai farm. That is, increase the flock of breeding animals from the 3 tiers of the population. There are the technical tricks we can apply to improve the accuracies of GABV. The first, including ways to adjust for the different accuracy of phenotypes between the genomic flock and the traditional breeder flocks. We can also try to find causative mutation or strong linkage disequilibrium markers by imputing whole genome sequencing for the more influential animals. This can allow to include markers in the evaluation model and to improve the accuracy of the evaluation. We can also try to dissect the traditional and innovative traits and use more precise trait definition and phenotypes closer to genotypes. This, for instance, can be done by milk spectra. These are tricks, but the most important work is try to plan efficiently the number, the size, and the flow of animals from and toward the genomic flocks in order to have a good connection between the selection candidates coming from the traditional breeder and user flocks and the genomic flocks. So we have to accurately simulate the scheme in order to define number, size, and flow of animals. An important thing to bear in mind is that as breeding programs continue, traditional breeders are likely to accumulate increasing number of male and possibly female genotypes, and this accumulation will enhance the accuracy of GBVs for traditional traits. So at the start, we can have low accuracies, but we expect that in the future they will increase. There are some social and organizational implications that can delay the effective starting of this approach. The most important, in my opinion, are to shift the mindset of farmers from using the traditional progeny test ramps to genomic evaluated ramps. Also shift the mindset from simple trait-based selection index to comprehensive multiple trait breeding objective. Another problem with our farmers is the important weight they give to breed standards that in some cases have negative impact on the genetic progress for economically important traits. And the other 2 points that are in my mind the most important, organize the collective management of the selective breeding scheme by the governance of the relations between genomic flocks, traditional breeders, users, and RAM center. RAM centers is important to collect the rams from the 3 tiers and to manage the flow of breeding animals between them. The other point, the most difficult, is implement an equitable model for sharing costs and benefits among breeding organizations, RAM center, the 3 tiers of farmers, and public research and government institutions. Thank you.
Thank you, Antonello. A lot of things to be discussed. I think we need a second follow-up meeting to discuss these aspects. I ask now the last speaker. I hope that we have a few minutes at least to summarize what has been discussed. So ask Dr. Badr Benzeloun, who works in INRA Morocco, and also is as a visiting scientist in CNRS in France. And he has participating in several research projects and initiatives on genomic diversity. And so I stop introducing and ask to follow the presentation. We cannot hear you.
Hi, Christina. Can you
Okay.
hear me now?
Yes,
Do you see my screen?
everything is fine. You start.
Perfect.
And
So, yeah, I'll start. Good afternoon, good morning, good evening, depending on where you are. It's not easy being the last speaker in this series. I hope the audience is not too tired. So I would like to thank you, Christina, for this nice introduction and for inviting me to contribute in this webinar series, where I'm going to present the context and the ongoing work that is being done within ScalaMidi project, which is a PRIMA Section 1 project to develop an innovative breeding program in local sheep in Morocco. So I will start with the current context of livestock and the main global constraints on this livestock sector, which are mainly climate change. Indeed, it impacts food resources, disease prevalence, productivity, and so on. And the second main constraint is genetic erosion, which comprises the sustainability of the flocks in many countries, especially for traditional breeds. So in this context, the ScalaMidi project, the main goal of ScalaMidi project is to optimize the sustainable use and conservation of local genetic resources from the Mediterranean region, focusing on adaptation to climate conditions and consumer preferences. So the project has 17 partners, 3 from Morocco, 3 from Algeria, 4 from Tunisia, 2 from France, and 5 from Italy. Its duration is 56 months. It started in 2021 and it will end in 2026. A budget of 1.75 million euros, and it's coordinated by UCEC in person of Paolo Aimon in Marsa. So the project has many purposes, and one of these specific purposes is to conceive and implement a new generation breeding program on a single local breed, which is the Moroccan Sardi sheep breed. I will start this section by how genetic improvements in indigenous Moroccan sheep is implemented. So I think it started in 1959 in the beginning, but for sure we had a national sheep plan in 1980 with an increased role of the Sheep and Goats National Association named ANOC. And this association has as missions within this program or within this plan to conserve an indigenous breed and their cradles or their regions of origin. And for this, the ANOC give financial support, veterinary support, and also technical to the breeders. And it's a very large association which is present all over of the country. And the second mission is the breed homogenization at the beginning and improvement. So for this, ANOC is supervising and implementing a traditional phenotypic selection system. And this is done for sheep and goats. And in sheep, we had 7 main breeds in which we have different breeding programs, but all those programs are based on phenotypes. So among this breed, there is Sardi breed, which is one of the main important breeds. I think it represents 12% of Moroccan sheep. It has impressive growing traits. And also it is important in the famous religious feast, which is Eid al-Adha here in Morocco. So it has an official breeding area of about 40,000 square kilometers, but this breed is present in an area of about 100,000 square kilometers. There is a mistake here in the screen. So it's raised in the central west plateau in Morocco, as shown in the map. It's adapted to the semi-arid climate. Temperatures can raise up to 45 degrees during the summer, and it is raised under a semi-intensive system based on grazing. So I will talk about the current specific breeding program of Sardi sheep. The breed is organized in 20 different groups, all of this region of its raising region. In this program of selection, there are 1,200 farms. Among them, there is 140 nucleus. The ewes that are under this program of selection program are 122,000 and 1,600 rams. So actually, this phenotypic selection, it has 2 stages. At the first stage, made by ANOC technicians, which are the technicians, the people from this association. It happened for around 4 to 6 months, and it consists of disqualify or eliminate the animals that are not satisfying breed standard, those that present major defects like testicular blindness, albinism, etc. The second stage selection, it happened about 15 months, and it consists of ranking of animals based on many traits linked to breed standard, which represent 20%. Some traits, qualitative traits, about 30% in this scoring, and finally meat production traits, which represent about 50%. Now I will try to will go to the Scala-MIDI breeding program, which aims to evolve this selection program in this specific breeds. So first, we try to identify in this project, for sure, it will be genomic selection, but we try to identify important traits. For this, we did a survey within the project and we asked each actors or each stakeholder what is the main objective for this breed, and we identified for farmers, experts, and consumers what is important. For sure, standard phenotype, it's important for farmers. Growth rate and carcass traits also, it's important for farmers still. And also disease resistance, adaptivity to harsh environment, drought, or low input system also. And finally, the reproductive efficiency, which mainly prolificacy, which is very important for the farmers. For experts, the main criteria is conservation of genetic variability. And for consumers, the main trait is meat quality. So for this, in this Scala-MIDI breeding program, the aim is to increase production traits, to maintain genetic diversity according to this survey that we conducted, and finally to increase adaptation traits. For this, we set up a reference population of about 3,000, which have been, so I will speak about genotyping and so on, but the reference population will be genotyped, but also phenotyped according to production traits, mainly production growing and reproduction traits and so on, but also we are phenotyping them for adaptation using innovative protocol which are based on sensors to track body temperature and oxygen saturation, heart rate variation, faced to heat stress or to the variation of the environmental parameters. And also we are typing them for breed standards, which are the traits important for breeders and breeder association. For genotypes, we are genotyping them using the 50K SNP genotyping from Affymetrix, but we did also some DNA methylation using Luma just to see the pattern of epigenetic of methylation over the genome. And for sure, with this for this reference population, we are using the pedigree which is present in the breeder, which is provided by the breeder association. So this reference population, as I said before, is spread over an area of more than 40,000 square kilometers. So we collected information on 3.3 thousand of individuals from 81 nucleus flocks, and all these individuals are phenotyped. We already genotyped 2,000 individuals, male and females, and we have 1K individuals that are ongoing, which is the progeny of the founder rams that we have. And we typed using Luma epigenetics techniques 860 individuals. What we already did is analyzed at this step genetic diversity using several parameters, epigenetics, and also we made association between phenotypes and climates. Just to give you a brief overview of these preliminary results linked mainly to genetic diversity. Here we have PCI results over these 2,000 of individuals. colors distinguish different groups of these animals. We have 14 groups spread over this sampling area of the area of this nucleus flux. And what we noticed from this figure in the left, that we have a weak genetic structure according to these groups. In the right, we have these 3 mixed results showing the very likely number of migration events using these arrows. We can notice that we have these high gene flows among this nucleus farm, which is important for this breeding program. We identified also multiple gene pools. So I will just to discuss, to present the ongoing work that is still ongoing. The first one is to analyze the association, climate, phenotype, given taken from the sensors, and genotype, climate, sensors, morphology also, and the genome data. We are testing breeding values accuracy using different prediction models, single-step G blob, empty multi-threads S&G blob, weighted single-step G blob, etc. What we are doing also, we are typing sheep from multiplier flux out of the nucleus. We are trying to phenotype and to genotype them, and we are running some socioeconomic modeling to see the impact, what we will expect from this breeding program. As a highlight, take-home message, we have now a pioneering genomics program in sheep in North Africa. In this program, we are trying to involve many innovative aspects using phenomics and epigenetics. We have several important prerequisites for the program. We have a strong breeder organization, a wide nucleus, genetic structure, etc. So we are expecting to have the first evaluation of genetic progress or breeding values and so on in the coming months. So actually, it's a huge team which is involved in this work, people from INRA, people also from ANOC, the National Sheep and Goats Association, which are involved in the project. And we have, for sure, we have people supervising the work, but we have also technicians in the field, and we have also other partners from different countries, from this involved in Scalamidi project, and also for sure all the Scalamidi consortium. So thank you very much for your attention. We'll end up with this.
Thank you very much. It has been the last talk, the last presentation, but it is a very interesting project, this the Scalamidi. We can have several things to discuss. I think I will ask Georgia, because now we're closing, we'll have a few minutes more. We can stay, I suppose, 10 minutes to discuss a little bit and more to summarize what has been said, because I think the discussion the presentations were interesting and raised a lot of aspects concerning the future of the genomic evaluation in sheep and goat breeding programs. What I could say from the things that I were represented, there are aspects of moving to change from progeny tested males to genomic evaluated males. There are aspects of accuracy of the generation interval and different approaches according to the breed, to the size of the breed, to the level of artificial insemination in the breeding scheme, several organization aspects concerning the collective management of the scheme, things about the cost and benefits. The discussion needs to continue. I mean, it has not started, I think. And the idea of the reference center that could be in the Mediterranean region, I think it is very, very important. And we have to find ways, I suppose, with the EAAP Study Commission on Ship and Goats, with ICAR, to open this discussion. And I think that the working group, the EAAP Mediterranean working group, is very much willing to facilitate this. So, Georgia, would you like to
Yes,
add, or the speakers, of course, to make
yes,
some ideas?
If I may add, Christina, first of all, thank you to every one of the speakers. I mean, the presentations have been extremely interesting and variable. And this is good because I think for me, at least, it's the first time that we collected so much information and so much issues that so many issues that are in common, or maybe not so in common, but maybe for us starting genomic evaluations, we see things that we will face as we continue. So this knowledge sharing and the development of a network, I think, would be very important. And I should emphasize also that as a president of the EAAP Sheep and Goat Commission, I'm also very willing to see if we can host a network within the commission to continue this discussion. And we can also even propose a session for, well, not for Innsbruck, because now the scientific program is closed, but for the following year in 2026 to have a challenge session where we can host the discussion even further. But even before then, I think we can see if we can organize another event, given the time limits now. I agree that there are many issues. I think every country should not reinvent the wheel. So things that work, they could be exchanged and implemented, and things that don't work, we shouldn't repeat aspects that are not working. And also, only good things can come from collaboration. So this is my feeling. So I don't know if anyone else from the speakers wants to add their view.
Would someone want to speak? Could raise hand. I would like to ask you, I think the regional EAAP meeting that will be in Sassari, so it's a good, if it has been decided, so it could be a good location to host something like that, but we need to start now the networking, and I see that
Yeah, Christina,
that is here, so
yeah,
maybe he would.
No,
some
thank you, Christina.
suggestions.
Thank you to you and Giorgio for organizing such a very nice webinar. But no, I just want to confirm that the next regional Mediterranean meeting will be held in Sassari in May 2026, so 1 year exactly from now. So, and this is a good suggestion for among the topics to discuss there.
Yes, thank you. It will be, we can work on that, because a lot of things have been raised during this webinar, and although we were rushed and we didn't have time to discuss after each presentation, I think we can continue the communication and be in contact and find ways that we build things together.
Yeah, and we will have other things also that will be produced, and yeah, I think we can discuss. It could be a good option to discuss together this, this networking and to exchange and so on. So, and I think we need this long discussion. I don't know, 1 day or 2 days if possible.
Yes.
But yeah, it could be very, very interesting. Right.
admit physically. I think
Yeah.
it helps because now here we don't see the reactions of the persons. We don't really know, but ideas came, and also you don't copy, you adapt to each situation.
Yeah.
The size of the population is very important.
I think there is Paulo who is
Ah,
who he wants to talk. Paulo Aimoni Marcel is the coordinator of the
yes,
Scala
know
Midi
him, but I
project.
don't know, Federico can write something, I suppose. Can only
think
write. That is the bad thing on webinars with so many people. I think, Paolo, you are only allowed to write.
Okay.
No,
not
he
to
can
speak.
speak.
Okay.
I think
Sorry.
he's open now.
It's open now, so everybody can speak.
Thank
Okay,
you very much. I was about to writing the message. No, I think I'm talking about Scala Medi, but this can be enlarged. I think Scala Medi is going to finish in March 2026, so in less than 1 year, and we are planning to have the final conference, I would say, at FAO. So this may be eventually enlarged, and maybe we can organize a larger event in which Scala Medi is one session, I would say, but the rest can be EAP or something like that. I mean, I'm open to discuss with you, Christina, or with
yes, it's a great idea.
or with Andrea as well, if something like that can be.
When will be this event?
Well, it is the project is going to finish in March 2026. So we have to organize the meeting before the end, at the end, but before the exact end of the project.
I guess, Paolo, there is something to discuss about this because our regional meeting is planned in May, and it will be after the end of the.
Okay. No, just an option, but
But we will talk about that to find a potential
okay.
solution that will be satisfy every eventual participants.
Just to join up.
No, that's a good
I
idea.
thought it was a different. We're talking about a different opportunity.
Yeah, that's a good idea. We'll talk, Paolo, about this.
Okay. Thank you.
Thank you.
Thank you, Paolo. Okay. Are there any ideas? Because some people, Antonello, Jean-Michel, to add on how to continue? Because there are also, okay, but there are to be discussed. There are, I realized from the examples that Jean-Michel, you have presented in the breeds in south of France, in fact, Lacan, which is a large, with a large size population, with a long extent genetic breeding program for years, and the smaller size population. So there are things to discuss concerning the cost and benefits that you get from genomic evaluation. These have also a place in discussion. And also how well the breeding program and all the structures around the British has been established. Because I think what has been said and realized is that the accuracy is important. And you need to have a good records for this.
Yes, one thing that was surprising at the start, we didn't think that genomic selection could decrease the generation interval, contrary to cattle. But actually, what we observe in France that with the genomic selection, the generation interval has decreased, because finally the people were willing to use the genomic rams. That means rams, young rams with only genomic EBVs, GEBVs, without daughters, and they were ready to use these genomic rams. That finally decreased the generation interval. So I just wanted to say that at the start we had some views about what could be the interest of genomic selection, for example, increase the accuracy. But at the end, we discovered that there were other interest and something that we didn't expect at the start. But yeah, the major thing is that in small ruminants, selection is not so easy as in dairy cattle, for example, and to improve selection, I think that networking is very interesting. And what you said at the start about yes, organizing other sessions or webinars, I think this is a good thing.
Okay. So we have to see how we'll do this. And so we stay in contact. So, Georgia, are we?
I think it's a good time to
close.
wrap up. I mean, we thank very much all the people that have been attending and have lasted more than 2 hours. It's a very important topic, obviously, and we will really explore all possible avenues of collaboration, also of exchange, and also yes, within EAAP activities and within the Mediterranean Working Group activities. Yes.
Yes.
Thank you all very much.
Thank you, everybody. And yes, we'll have to stay in contact in some way, follow EAAP, the news, to continue this interesting discussion.